Hello, Algebra 2 folks, and welcome to the last day of evaluating functions. Today we're going to use all of our previous knowledge that we've learned. We're going to need to know how to draw an angle. We're going to need to know how to find our reference angle. We're going to need to know how to find our reference triangle. We're going to have to be able to convert from radians to degrees. We're going to need to know our trig function setup, SOHCAHTOA, and the inverse. All the inverses, cotangent, secant, cosecant. We're going to need to use our unit circle, that green chart. We're going to need the special triangles that we had from a few weeks ago, the 30, 60, 90 triangles, the 45, 45, 90 triangles. All of that knowledge needs to be brought together today. You should have all of that stuff out on your desk, along with your notes, a pencil, and a calculator, and we will get started. So we want you to find the exact value of this trig function, and you need to be able to show all your work. That means you need to draw the angle. You need to tell me what the reference angle is. So all of this stuff needs to be there. All right, so let's first talk about negative 225. So let's draw a negative 225 degree angle. So we're going to draw a negative 225 degree angle. So I'm going to start here. Negative is clockwise. 225 brings me to about there. Draw my terminal side. Okay, there's my terminal side. And now what I'm going to do is draw my reference triangle. So drop a 90 down to the 180. My reference angle is here, and I need to figure out what that value is. Now remember, reference angles have to be less than 90, and it's closest to 180, so we're going to take 225 minus 180, and that's going to give me a 45 degree reference angle. So I have a 45 degree reference angle. Okay, so that means I have a 45, 45, 90 triangle. And if I know my 45, 45, 90 triangle rules, okay, my special triangle rules, then this will be a piece of cake. So now this is in this quadrant. This is quadrant 2, okay? So my 45, 45, 90 rules say these are the same, whatever these are. So if this is x, this is x, this is x square root of 2. Okay, but we have to be a little bit careful here because we have a second quadrant happening. We really don't know that this is a 1. It's actually a negative 1 because it's in the second quadrant. So the negatives are really going to matter here. So this is a negative 1 unit. This is a positive 1 unit. Now, remember I talked about this yesterday. The hypotenuse is always positive no matter what the x and y are. So the hypotenuse is still going to be 1 square root of 2. Okay? So no matter what, the hypotenuse is always going to stay positive. But we have to be careful because if we're talking about a positive angle, then we'd have a positive x value. So you have to really be careful making sure that you have it in the correct quadrant and your x's and y's are set up correctly. So this is my reference angle. This is where I'm going to be standing. Remember, it's always closest to the origin. And we have figured out the sides of our triangles based on our special 45, 45, 90 rules. And now we can evaluate this triangle just for the cosine. Notice I'm not going to ask you here to do all 6. I'm asking you to do one of the 6. And this one happens to be the cosine. And cosine is adjacent over hypotenuse. So if I'm standing here, adjacent would be negative 1 over hypotenuse, which would be the square root of 2. And then what you would do is you would then multiply the top by the square root of 2, rationalizing your denominator, multiply the bottom by the square root of 2, and you get negative square roots of 2 over 2. And that would be the answer. Okay, so you have to be careful. You've got to put your triangle in the correct spot, and the negatives and the positives really do matter. Okay, let's try another one. The secant of 300. So now I'm going to draw a 300-degree angle. So that's counterclockwise. 300 puts me to here. Okay, 300-degree angle. I need to find my reference angle. So I'm going to drop my 90-degree here. My reference angle is right here. This is my reference triangle. 300 minus 360, or 360 minus 300 would be a 60-degree reference angle. This would be a 30-degree then, and then that's your 90. So this is the long leg, this is the short leg, and this is the hypotenuse. And if you remember your special rules for a 30, 60, 90, this will really be helpful. So remember, we could say if the short leg is 1, the hypotenuse is double that. And if the short leg is 1, the long leg is 1 times the square root of 3. All right, so remembering the rules is going to be very helpful. Okay, so if the short leg is 1, the hypotenuse is 2. If the short leg is 1, then the long leg is 1 square roots of 3. But now, be careful. We need to look at these and go, do we have the right negative or positive sign? This would be a positive x, this would be a negative x. So this should be really -1 square roots of 3 because I'm going down to get to this point right here. And then the hypotenuse, remember, is always positive, okay? So you got to remember that the negatives and the positives do make a difference. All right, so now that we have our reference angle, our reference triangle, and all the sides because of the special rules, then we can evaluate the secant. Well, the secant, remember, is the inverse of cosine. So that's hypotenuse over adjacent. So this is my reference angle. That's where I'm standing. Hypotenuse would be 2, and adjacent would be 1. And so this would be 2. So the secant of 300 is equal to 2. Okay, let's try it again. Find the exact value of the trig function. Here we got cotangent of -8 pi over 3. Well, I don't know what 8 pi over 3 is, so I'm going to have to do x over 360 is equal to -8/3 pi over 2 pi. 2 pi times x is 2 pi x. 360 times -8/3 is -960 pi. Divide by 2 pi, and x equals -480 degrees. So we need to draw a -480 degrees. So we're going to go all the way around. That's 360. And then we're going to go a little bit more to here. All right, so this is my -480 degree angle. And I need to draw my reference triangle. So drop a 90 and find my reference angle. Well, I went around 360, so I got to get 360 away from that. That would give me 120. And then that isn't big enough. I mean, that's too big. 120 cannot be my reference angle. So then I'm going to take 180 minus 120. And that'll give me a 60-degree reference angle. Remember, your reference angle has to be less than 90. Okay, so if you went around all the way around 360, you're going to have to take an account for that one revolution of 360, which gives us to 120, and 180 minus 120 is 60. So again, I have a 30, 60, 90 triangle. This is my short leg. This is my long leg, and this is my hypotenuse. And remember, short leg, if that is 1, but in this case, it wouldn't be a positive 1 because we're in quadrant 3, so we're in -1. This is going to be the long leg, which is times the square root of 3, and we're going down into the quadrant 3. So if we're in quadrant 3, this would be negative square roots of 3 again. Okay, got to make sure that our negatives are where our triangle is. Okay, that's what makes the difference. We can use our reference angle, and then we can, if we use the correct negatives and positives, we can get the right answer. And then the hypotenuse is always double the short leg, so that's 2, and that's always positive because hypotenuse is always positive. When you square a negative and you square another negative, you always get a positive. So the hypotenuse is always positive. All right, so now that I have my special triangle rules and my parts labeled, I can take and find the cotangent. The cotangent is, if I know tangent is O over A, then I know that cotangent is A over O, because they're inverses of each other. So whatever A is, so I'm standing right here, so my adjacent would be negative 1, opposite would be negative square roots of 3, okay? That negative and a negative make a positive, so I have 1 over the square root of 3. I'm going to multiply the top by the square root of 3 and the bottom by the square root of 3 to rationalize my denominator, and I get 1 square roots of 3 over the square root of 9, which is 3. Okay, and that would be the cotangent of negative 480 degrees. All right, let's do one more. All right, let's find the exact value of the trig function at tangent of negative 3 pi over 4. So negative 3 pi over 4, let's go x over 360 is equal to negative 3 pi over 4 over 2 pi. That's 2 pi x equals 360 times 3/4 would be 270 pi, divide by 2 pi, that'd be negative 270, I'm sorry, because I needed to take it times negative 3 over 4, divided by 2 pi, the pi's cancel, and I get x equals negative 135 degrees. So I'm looking for an angle of 135. So if I draw my 135 degree angle, negative 135, that will put me here, negative 135 degree angle. I need to drop my reference triangle. I need to draw the reference triangle, the 90 degrees, and find my reference angle. That's closest to 180. So I'm going to take 180 minus 135, and I get a 45 degree reference angle. And that will be a 45, 45, 90 triangle. If I'm in the third quadrant again, I need to make sure that I label my sides correctly. This would be normally 1, but it's negative 1. This would normally be 1, but because I'm in the third quadrant, it's negative 1. And this is always the sides times the square root of 2, but remember, it's always positive, so it's positive square roots of 2. So these are my sides of this triangle, and now I can find the tangent of negative 135. So if I'm standing here, it's opposite over adjacent. Opposite would be negative 1, adjacent would be negative 1, so the tangent of negative 135 would be a positive 1. All right, thank you for taking good notes. Come back tomorrow with questions and we will practice this some more.